We are continuing with the material from section 9.1 on trig identities, and we're going to look at an exercise that involves verifying a trig identity. And so let's talk about exactly what this means. So the instructions for our exercise are just that: verify the identity. And the identity that we're looking at is this equation. Quite a mess, right? 1 minus sine x over 1 plus sine x equals secant x minus tan x in parentheses squared. What we want to do is show that this equation is true for all values of x whenever that equation is defined. And so what it means, and let's just maybe reword this a little bit, when we verify an identity, we want to show that one side of the equation is always equal to the other side. And my equation here has one side is 1 minus sine x over 1 plus sine x. We're going to call that the left-hand side of the equation. And sometimes I'm going to abbreviate that with LHS. So LHS just stands for left-hand side. And on the other side of the equal sign, the expression in parentheses here, squared, is the right-hand side. So I'll abbreviate that RHS. When we're verifying a trig identity, what we have to do to get started is we have to choose one of these two sides of the equation to work on. So we pick one side of the equation to work on. And now how do we do that? Well, sometimes you can start with either side. Sometimes one side is easier than the other. Here, when I examine the problem we have in this exercise, 1 minus sine x over 1 plus sine x is the left-hand side. I don't really see anything that I can do here to simplify that or rewrite it, and it's already written in a pretty basic form. But the right-hand side of this equation, secant x minus tan x in parentheses squared, it does look like there are things I can do to rewrite it. For instance, I can rewrite secant and tangent in terms of sine and cosine. So I'm actually going to choose the right-hand side to start here. I'm going to recopy the right-hand side, so let me write RHS here, which is secant x minus tan x in parentheses squared. And I'm going to try to simplify that. I'm going to try to rewrite it. And I'm going to try to get it to look like the left-hand side. I don't know exactly what's the best thing to do here. I just start rewriting in any way that makes sense. So for instance, here I can take the right-hand side and rewrite secant as 1 over cosine x minus tangent is sine x over cosine x, all in parentheses squared. This strategy of rewriting the functions in terms of sine and cosine is often a very good strategy to use because notice that already I don't know, to me it looks less scary somehow just being written in terms of sine and cosine. Now, is there anything I can do to work on this right-hand side? I notice here I have a common denominator of cosine x for the two fractions in parentheses. So I can actually combine those into a single fraction. I can write 1 minus sine x over cosine x in parentheses squared. And now because I have a fraction squared, I could rewrite this as the numerator 1 minus sine x in parentheses squared over cosine x in parentheses squared. Now I am trying to end up with an expression that looks like the left-hand side of our original problem, which is up here. So I'm actually feeling a little bit good about this because I see this 1 minus sine x in the numerator, which we want to end up with a 1 minus sine x for the left-hand side. I don't want the square though, so that's going to be something I'm going to have to figure out how to deal with. Now I want to continue to try to rewrite this. You might be tempted to multiply out the numerator. Since I can write that as 1 minus sine x times 1 minus sine x. I'm not going to multiply it out though because I don't want to lose that 1 minus sine x that I see in parentheses because if I multiply it out I won't have that 1 minus sine x that we're trying to obtain in our left-hand side numerator. What I'm going to do though is I'm going to rewrite the denominator. And this is an important little trick to learn when you're working with identities. I'm actually going to use that most famous trig identity, the Pythagorean identity, sine squared x plus cosine squared x equals 1. And if I isolate cosine squared x in that equation, cosine squared x is equal to 1 minus sine squared x. Now, cosine squared x is just our shorthand, right, for writing cosine x in parentheses squared. So what I can do is I can use this relationship to replace the cosine x squared in the denominator of my fraction here with 1 minus sine squared x, because that's equivalent. Let's go ahead and do that. I'm recopying the numerator, 1 minus sine x in parentheses squared over 1 minus sine squared x. Now I got to admit, it's not obvious where this is headed at this point. I'm making this substitution, and yet now I guess one reason I like this is I have all signs involved, and I am trying to get a fraction that only has sines and no cosines. So I guess that's one way to think of why this might have been a good move. Now, so that was a very clever kind of change to make where I replaced cosine x squared with 1 minus sine squared. I'm going to make another change here that involves thinking about factoring. This 1 minus sine squared x, that really has the form a squared minus b squared, a difference of squares. And we know that form factors as a minus b times a plus b. So this 1 minus sine squared x can be thought of as 1 squared minus sine x squared, which will factor as 1 minus sine x times 1 plus sine x. This denominator, 1 minus sine squared, then can be replaced with this factored form that I obtained on the right here. So let's go ahead and rewrite this now. I have 1 minus sine x squared over 1 minus sine x times 1 plus sine x. Now this is actually a great move to make, because that numerator, because I have an expression in parentheses squared, that numerator is just the expression in parentheses times itself. 1 minus sine x times 1 minus sine x. We now know the denominator is 1 minus sine x times 1 plus sine x. And what I see at this point is that I have a factor in parentheses that can cancel. The 1 minus sine x above and below can be canceled. And I'm left with just 1 minus sine x over 1 plus sine x. And that's exactly the left-hand side, which is what we were trying to obtain. I've shown that I can get from the right-hand side by rewriting and simplifying, and get to the left-hand side. So we're done. We have verified the identity. I'm just going to try to zoom out a little bit here so I can get the whole problem on one screen.